If you are not all the way done with both of the problems, that's okay. Keep working on it and then just kind of check up, look up as I go through the answer to number 1. So first thing I would do on number 1, I'm going to make my tree diagram. These first branches should be what? Forbidden or not forbidden. So I'm going to put that on the other spot. Forbidden, not forbidden. And then whether a person is bringing an item that they're not supposed to or not, everybody's got to go through the screening machines. Do the screening machines catch everything perfectly? No, people still get away with stuff that they're not supposed to. Do sometimes people get flagged even though they don't have anything that they're not supposed to have? Yes, that happened to me the other day. They yelled at me for my bracelet. All right, so triggers the alarm, does not trigger the alarm. Triggers the alarm, does not trigger the alarm. Ooh, sorry, that zoomed way in. There we go. 5% of the bags contain a forbidden item. So I'm going to have 0.05 up here. So how many people are good and don't bring a forbidden item with them? 0.095. Sorry, not 0.095, 0.95. Meh. 95% of people don't bring a forbidden item, 5% do. Suppose the bag contains a forbidden item. So now I've already followed this path up here. If the bag contains the forbidden item, there's a 98% chance that it's going to trigger the alarm. So what percentage of people that are bringing forbidden items don't get flagged? 2%, 0.02. Bags that don't contain forbidden items, there's an 8% chance that it triggers the alarm. So 0.08. Those poor people get to stand in line and get wanded down. 92% of the people that don't have a forbidden item get through security without a problem. So far, so good? All right. Then you would multiply along the branches to get your probabilities. So you should have gotten 0.049 for a forbidden item that triggers the alarm. You should have gotten 0.076 for not having a forbidden item that triggers the alarm. So the probability that somebody has a forbidden item and they given that the alarm was triggered, what's the probability that they have a forbidden item? So forbidden and alarm is 0.049. To get the probability that the alarm was triggered, I have to take these two outcomes because the alarm was triggered in both of those, and I have to add them together. I'm allowed to just add them together because these two events are mutually exclusive. There is nobody that has a forbidden item, the alarm was tripped, and they don't have a forbidden item, and the alarm was tripped. So I divide those two, and I get 0.392. So that means most of the time that the alarm goes off, almost 60% of the, or more than 60% of the time, when the alarm goes off, are they actually going to find a forbidden item? No. When the alarm goes off, only 40% of the time are they finding something that shouldn't have gotten through. All right. The next problem, number 2. And we did find a typo here. It should be not test is perfect, though it should say no test is perfect. 99% of the patients who have the disease will test positive. So positive complement. Or sorry, have the disease, doesn't have the disease.
I was right.
Disease complement, sorry. 99% of the patients who have the disease will test positive. So what we're looking at here, because here's positive complement. Positive complement. I'm going to start at the bottom. 10% of the population has the disease, so 0.10. That means 90% of the population does not have the disease. 5% of the patients who don't have the disease will test positive. So if you test negative and you don't have the disease, there's like 95% of the people are going to fit in that category. 99% of the patients who have the disease are going to test positive. 1% of the people are going to escape detection. They're going to pop a false negative. So here's my completed tree diagram with my probabilities. The probability that someone has the disease, given that we know they tested positive. Here's our 2 outcomes where they tested positive. I have to add those together to get the probability of a positive test. And then my intersection up on top. So if somebody tests positive, there's a 68.75% chance that they actually have the disease. Tomorrow we're going to do a free response question and hopefully have some time for multiple choice. That is my plan. Thursday, I will take any questions you guys have off of the test review.